Well, hi, good morning. Thanks so much for joining me here in my shop for what hopefully is going to be a very good session. I'm going to be focused on the FM receiver of the radio, at least that's what I'm planning. And unless something else rears its head, some other kind of problem, which is quite possible, maybe even likely in this radio, a problem with buttons, problem with who knows what, I should be able to just concentrate on the situation with the FM receiver. So just a quick review for my own sake of where I'm at with this. On the FM receiver, I have done the 10.7 IF frequency alignment. There was one unsatisfactory or questionable point in it where I made one of the where I found one of the adjustments didn't seem to have any effect. That's still a serious kind of concern. It could just be the way it is with this radio, or it could be indicating something's wrong that was in the second IF transformer. Another thing is the output, as I understand it and have witnessed many times, is very low. There could be all kinds of reasons for that offhand, so that in itself doesn't help much. It just kind of tells me something is wrong somewhere. I've had a lot of trouble with cleaning these switches. The FM switch, there's no reason to think it might have problems itself, and may still have enough dirt in it that it's not actually switching, and that may be the source of the whole problem. I don't think so, because usually that kind of problem, as you operate the switch, kind of makes itself known, and the switch has been absolutely consistent so far. It hasn't indicated at any time that the switch is part of the problem. That doesn't mean it isn't, it just means it's not as likely as other things. Another possibility is bad alignment. This is not the highest likelihood. The alignment, there's two basic alignment areas, the IF, which I've done. Perhaps I should be checking. Maybe the next step is to check the IF alignment on FM. Maybe that's the next step. I've got a couple things rolling through my head there as I'm saying that. Another possibility is the alignment and adjustments right up here in the tuner are off, and that's the part that's not all that likely. Some of the adjustments are just oscillator adjustments. It just kind of affect where you are on with the dial accuracy in that. Shouldn't make the receiver weak. And the other adjustments, unless they're way off, shouldn't make the receiver as weak as they are. And what are the chances that this is off? Not all that great. Not all that great. The tube has been tested more than once. It's a strong tube. The pin resistance has been measured in here, and the pin resistances were proper. That suggests that it's probably receiving the correct voltages, although I haven't tested that directly. That's something that maybe I could do. It's low impact, easy to do. Just pull the tube out and take voltage readings. Of course, with the tube out, the voltage readings are a little different. You can't read the tube from the pin side because it's in this box and it's not accessible. Another option for me is to get out test equipment and somehow determine where the signal is weak. Basically do signal tracing. I tried a little of that early on. This is a great point here to test because this is the output from the tuner. It's coming out of here at 10.7 and heading down to the IF. If it's weak here, it's weak coming out the speakers. But exactly how you know it's weak there is tricky. Hooking up any equipment to this point throws it off, so to speak. It detunes it, so the equipment itself can be responsible for the low readings that might follow. I tried a loose coupling technique using my Sdr. I just kind of rolled it around here. I didn't really focus on doing that. The problem with doing that is recognizing what the results mean. I don't have any experience in doing that with an Sdr. don't know really what to expect. Perhaps signal to noise ratio might indicate something about the strength of the signal coming out of here. Could be weak here, it could be just fine here. So the normal process in tuning up a radio, AM or FM, is you ensure the IF is working properly and then attend to things in the front end. So I've kind of done that by going through the alignment process here. I just did that with a simple single frequency approach and no attempt to see the response curve in here. But by feeding in an alternate signal here and then picking it up at the end, it's again very hard to judge whether there's some weakness in here. You know, a remote possibility is the IF tube can't amplify at 10.7. It seems to be doing an okay job at 460 kilohertz. 10.7 is quite a bit higher. These tubes tend to weaken at the higher frequencies first, I believe. But I think that's very unlikely too. This tube tests very good. I think that's unlikely. 10.7 isn't ridiculously high. So in thinking about all these things, I think my next best step would be to ensure that, or try to ensure that the IF is properly adjusted. Okay, I think I'd want to do it using a more graphical method, using a sweep and looking at it on the oscilloscope. I think is the way. I always have trouble doing this. I've always had trouble doing this. So it's difficult to set up effectively, I find, at least for me. So I think that's a fair bit right there, just to get the test to operate, let alone make adjustments in the radio. Okay, that sounds like a good idea to me. I think I'm going to check with a different approach the tuning of the two IF transformers. Okay, so I've been studying up on the instructions. Looks like I may have made a bit of a mistake first time around and injected the test signal for the FM alignment process into this tube. I really should have been injecting it into this tube. That's done with just a tube cover like this. And you just hook up a signal generator to this, and enough signal gets in the tube to do the job. Don't know if that really made much of a difference in the end. So normally I would turn to this piece of equipment to do these alignments. This thing will put out a radio signal at 100 megahertz, and it has different facilities to assist with the alignment and adjustment of a radio like this. But I cannot fulfill the alignment instructions as written using this device. This thing will not produce the 10.7 IF signal that I need. And in order to do this using a sweep, I have to use a sweep generator. A sweep generator that'll sweep around 10.7 megahertz. And the one I have in here is this TV sweep generator here. Now, I've tried to employ this in the past. I spent time working on it. It has an additional circuit put in by somebody with some definite skills, an additional circuit to try to improve its operation. That circuit doesn't appear to work quite right, and I never completed the investigation or the restoration of that additional circuit. That aside, this thing can put out 10.7, and then it can sweep it back and forth frequency-wise, regardless of this other additional circuit. So the difficulty with a device like this is, how do you know it's on 10.7? By reading this dial? I don't think so. So in order to know what is coming out of this, I want to employ my Sdr radio. So I can get a look at it on the Sdr. I can identify what frequency it's sweeping around and make sure it's doing what it has to do to help with the help with checking the alignment on this radio. I haven't had much luck in doing this. I tend to find it just becomes kind of too much, but I'm going to give it a shot anyway. I don't have any other sweep generators in here. I have other generators that'll produce 10.7, but not in a sweep. So that's why I'm going to try this one. So I'm going to spend a little bit of time off camera getting all this going, at least to a point where it's interesting, and then we'll take it from there. Okay, I think I'm ready for step one. Make that machine work. So the output from here is looping around and coming back to here. And it's hooked up to this green clip lead, which is just looped. Okay, it's just a loop. There's another loop here, which is hooked up to this cable, which is the antenna input for the SDR you're looking at down below. Not much response there, right? Just double checking these things. Yeah, there we go. SDR is delayed by a little bit, about almost a second, in fact. Okay, so we're gonna switch this guy on and try to see the signal on the SDR. The SDR is tuned, as you can see, to 10.7. That's where the red line is, at 10.7. Okay, so sweep width, turn down, find attenuator, stick it in the middle. Attenuator going out. We don't want it to attenuate at all, so we're going to put it on ×1. So we want to be on 10.7. 10.7 is right at the end of this band I'm pointing at here. So that's band B, so we're on band B. One of the bands on here does not work, if I remember right. The marker is turned off. The marker isn't going to help us in this because of the problems in here, but I have another. If needed, we can bring on another marker amplifier, but we shouldn't need it because I believe because the SDR is going to reveal much more than any marker would. I think we're ready. Here we go. I'm just watching the SDR to see if something pops up. Oh, I have to turn this right around 10.7. Okay, so that's somewhere around 10.7. See if we get anything out of it. Bingo. Mucho. We got all kinds of stuff. Lots of stuff coming out of it. So now the SDR has its own difficulties with signals. So some of those could be artifacts, like for instance this signal right here. It seems to be identical to this very strong signal over here. What is what? Wow, okay, this is off to a rough start. Let's turn the attenuator down. Yeah. Okay, so we got rid of some of those. Now we're going to vary the frequency here and watch what changes. So interestingly enough, this signal right here didn't move. Is it somehow related to this adjustment? No, this shouldn't be doing anything, this one. Oh, it is doing something. So there's something over on the right there. Let me move it more slowly. The SDR, when a varying frequency is presented to the SDR, it can't process it fast enough to put it on the screen. So if you have a varying frequency, the SDR may not show it. So I'm gonna, yeah, look at this, there's a hair trigger here. It's way over there. According to the dial, we're at 35 megahertz, nowhere near where we need to go. In fact, this oscillator shouldn't reach down into these frequencies. So what's going on? I don't know. Marker off. Oh, wasn't off. It was low. Now it's off. Okay, let's keep that in mind. Now again, this fixed frequency, the frequency that's just to the left of the yellow line, of the red line. Move this around a bit. Okay, so I don't know what that is. Some oscillation coming out of this guy right near 10.7. Tell me this thing has a 10.7 automatic marker built into it. That's just a little bit off. I don't think so. Here's a crystal. I'm going to pull this out. nothing's going to happen. And this crystal is for 3.037. And if you multiply that by 3, you get 9. You don't get 10.7. This shouldn't be doing anything. For some reason, that looks like a swept signal there. Let's just adjust the sweep. Well, see, it just leap right out. It's a huge sweep now. Okay, so we're getting there. We can't zero the sweep. It's probably not a real problem. No, so what I do, put the middle of that, put the middle of it on the red line. And the weird formation of the sweep could be the SDR doing its best to respond to this thing. The sweep itself, I believe, is 60 cycles. Going back, it is. It's going back and forth at 60 cycles. And probably the SDR is causing that shake. Now, there are some SDR adjustments I can fiddle around with here. These adjustments here, these are on the screen, are they? Not quite. Let me close this thing up here. Okay, so most of them have made it on the screen. So S attack, S decay. What happened to our display here? I didn't adjust anything yet, did I? What happened? Did I bump one of these? Looks like there's no decay here. Let's see. Maybe I bumped this one. I'll try and get rid of the W decay and see what happens. So these two W attack, W decay are for the waterfall display, which you can't see right now. It's off the screen. It's below the screen. You can't even see what I'm doing. These two, S attack and S decay, are for the signal up above here. So if we speed up the attack, it gets even shakier. If we speed up the decay, it gets even shakier yet. Yeah, I think it's recording exactly what I'm seeing on my computer screen, so that's a little hard to look at, isn't it? So if we slow the attack down so it doesn't slow it way down. That's too low. That's a 0. Open just a little bit. Looks like it's drifting a little bit too, drifting down. And we change the decay. So I'm trying to make a nice smooth result. That's a little too low. I can't go any lower without. Basically, it's recording the maximum. So, but we do need some decay in here. So that's a minimal decay I can set. Let's drift it down around that other signal. Very suspicious other signal. So I'm going to adjust this back up a bit. Oh, you can see my computer screen I'm looking at on the camera. Oh, turning the wrong thing. Oop. I swear I'm turning this up and it's going down in frequency. Well, what's that all about? This is set now to 11.2, but there's no accuracy in this. I'm going to swing this all over the place and see what's going on, because see how low it is, because the SDR can't process it fast enough to show you the full height. Is there anything else? Oh, there's something else coming along. This is up at B scale 13 something, so wow, there's all kinds of nonsense coming out of this machine here. Let's keep going up. Really shouldn't matter too much. Oh, there's another little thing there. It's at 16, 17. Just exploring this machine. Notice that other signal is kind of faded out into nothing. Let's go back down again. That's quite interesting. Why is that there? There comes the first one. Probably use any of these signals that we choose, like this one here. Just above 11. There's basically two of them, for reasons I don't know. And that signal's going down again, the one that's fixed. It's definitely coming out of this guy. Okay, let's pick one. Pick this one. Okay, we'll try to center it there. I'm really quite worried about that other signal. It's so close to 10.7. Okay, we're going to increase the sweep width. So the Sdr has a harder and harder time showing the full size of this, I think, as I widen it out. I think it looks weaker and weaker as we go, I think. Okay, so if I shrink it right back, this is coming up on the minus 50. Yeah, it's a little higher when the sweep isn't wide. If the center is wandering off too, that's quite possible. So the idea is to put a sweep signal like this onto the temporary tube shield and have this centered on 10.7. That would appear to be a little tricky. What are the chances that this is the center? I'm going to move this, well, we can check it right here, a little to the left of this line. So that makes it 2 divisions this way. Okay, a little to the right of this line rather. It should be 1, 2, so you see it's not centered. You know what, this might be the center. Would this be the center? Let's put this in the center. I can't move it. I cannot move this. This suspicious thing here, which I don't think is supposed to be there. What frequency is that actually? 10.640, 10 point. So it's 60 kilohertz off. We have to, try to view this on an oscilloscope or some other method. I don't have another method, unless the Sdr does that too for us. I'm going to have to let this warm up for quite a while before doing anything with it. Now, is this really in the middle? 10.640. So go up here. 11.250. Oh, guys, this is too difficult math for me. Let's just count. 1/2, 2, 3, 2.5. We go this way. So it's 2 in one direction, 2.5 in the other. So I don't think this is supposed to be 10.7. I don't remember ever reading that this thing had a 10.7 signal in it. How can I get rid of it? I've already tried a couple of things. What about this attenuator? Let me just turn up the level with this. No, it comes right back. Is that really going to cause a problem? Good question. I don't know. Could it be coming from something else? No, it can't be. It has to be coming out of that box. Is it an artifact of the Sdr? I don't think so. Did we listen to it? What does it sound like? course, the SDR has this sweep running through. The signal is shooting back and forth in a circular sort of motion, if you like it. It's going to hang out here a little bit, come quickly through here, hang out here a little bit. That's why the SDR is showing it higher, because it's more time spent here. So you get this bathtub shape here, just an SDR effect. And the sound we hear is the signal sweeping back and forth across the red line, thump, 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 60 times a second. And that sounds like this. So we're not really hearing this signal. Hello, Peanut. Now what we can do is we can move the sweep out of there. Yeah. There's a cat. There's a cat in my radio. We're going to turn this on, and we're going to move the sweep out of there. Let's go the other way. So now on the SDR, we're listening just to this thing. So there's quite a hum in that beast. Oh my gosh, Peanut! What is going on? Can you just hold the fort for a few minutes? Hold the fort. Do you understand that phrase? He appears to. So, again, what exactly this is it going to interfere? Son of a gun. I'm going to set this back. Okay, we don't have to listen to that. I'm going to set it to an exact balance here, if I can. But we're not on 10.7 anymore, Jim. Come on. 10.7. Okay, we want to balance it around that. Let me expand this a bit, because it will change the scale. Good. Now we have a 10.7 right on here. Where'd the sweep go? So the sweep has gone off both sides of the screen. You can't see it, so I'm going to reduce the sweep, bring it in, and now I'm going to be able to center it once it settles down. So we got to move it this way a little wee bit, this way a little wee bit. So that's 1, 2, 3 on one side, 1, 2, 3 and a bit on the other. So we need to move it just a hair here. Okay, that's nicely centered on 10.7. I'm going to leave it like that, go play with my cat for a while, and when I come back we'll see what's happened to it. We'll see if it's drifted. If it hasn't drifted, then I'm ready to start fooling around with the radio itself. Right, Peanut? Oh, he wants to go outside, but there's still lots of snow on the ground, although it is disappearing slowly. Fantastic. Did this thing already drift? You can see it drifting to the left. Yeah, better just let it sit and warm up for quite a while. Okay, Peanut. Let's go. Okay, well, it's been quite a while, and where is the sweep signal? It's probably just gone way off. Let's go and hunt for it here. There it is. Way, way, way down here. Let me just switch this to... No, I'll leave it like that for now. The next challenge is to get something to appear on this scope. Something useful to appear on the scope here. So this device is sweeping back and forth at 60 cycles. And it has a blanking feature in it, which is quite unusual. These outputs down here are the horizontal output to be used on the oscilloscope. So we're gonna hook this up. We're gonna switch this to XY. Just back that down a little bit. So this becomes the horizontal here. Just Okay, let's see if we can just darken things down a little bit. Make it easier to see the scope. Okay, so I'm going to hook up the scope to here. We have ground to the right. Watch the scope. Nothing seemed to happen there. Okay, we are looking at channel 1. Uncalibrated mode. Now it's calibrated. Nothing happening, so this should be going back and forth. Oh, this is on ground. There we are. Good. So there's the sweep. Just center it here. So again, this is like a circle laid flat. So you're looking at it like this. It ends up looking like a straight line. Speed is fast in the middle, slow on the edges. That's why it's slightly brighter on the edges here, which is a little hard to see in the camera, but it is. So we've successfully got the sweep going there. Now on the vertical, we want the output of the radio, ultimately, from somewhere on the radio. So what to start with, what would I put there? What would I, just to experiment with? You kind of get a similar display to what's on the SDR. Kinda. Well, it could go on just the output of the signal generator. Here. That's set to 5 volts. I'm on the times 10. I'm going to clip this right onto the output here. So ground goes to ground. Hook this here. Not really sure what I'm doing. Doing something though. Okay. Don't see much. I see something there. So I don't think this is a useful thing, what I've done, but at least it shows. So we're kind of looking at RF being swept back and forth. Right. Since there is no nothing to shape the signal, it's really just a rectangle here. Okay, I think this all is good. See, the output is fairly stable on the SDR now. How warm is this box getting? Fairly warm, but okay. I think we're pretty close now to trying to inject the sweep signal into the radio here. And somehow managing to see something really on the oscilloscope is really what we're after. The purpose of the SDR is to keep an eye on the signal. Okay. I think it's yeah. Okay, I'm going to figure something out here. I'll stop and figure things out. Okay, we've got a fairly busy screen to look at now. Obviously lower left SDR, upper right is a camera on my oscilloscope. And the deal is the radio now. So, what I've done here is I put the sleeve over top of this tube. This is the mixer tube, FM mixer tube. And then I have a yellow clip lead going back to another coil I've just thrown on here. This is just a random coil of wire I have. And the other side is just clip leaded to the chassis of the radio. Okay, I think we're ready to turn this guy on. Volume down, speakers are connected. Okay. I think we're ready. Here we go. Okay. Not quite, didn't plug it in. Did not plug it into the power. There we go. So everything's drifting off, but that's okay. Now you can see the waterfall display on the SDR, so you can really tell where the sweep is. It's off to the left there. We'll leave it there for now. So I want to turn this guy on and make sure it's working. So we'll put on broadcast to start with. Here we go. Very good. Also good. Give it a moment. Well, what we're going to see in the end here, I'm not sure. I still don't have the scope connected in some acceptable way here. I kind of slipped up on that. So we're listening in the broadcast band. We can be pretty sure what we're hearing is the effect of probably the old signal generator is doing that. The radio appears to be working. Volume's good. Okay, straight to FM. Wow, that's the most hiss I've ever gotten out of this radio. It's working. Stop, stop. Is it working? This is with no antenna. Oh, if you put an antenna on that, wouldn't it? Maybe there's nothing wrong after all this. Okay, let's carry on though. So I'm going to turn to a spot where there's no station. No station they can hear. And I'm going to adjust the signal generator to get it back on 10.7. We'll hear what comes out of this radio, if anything. Here we go. That means a couple things. One is this whole setup is not working. That's probably the case. Probably where I'm trying to bring the signal over. It's just too weak from this kind of arrangement here. Or the alignment is so far off, I never got there. Let's try that. So the easy thing I can do is just to expand the sweep. And see if we hear it in there. Okay, so the sweep is going way out now. Wait a minute, what's that? Hang on a second here. Hang on a second here. A little bit of trouble explaining what's happening. Could be what we were seeing on the SDR is an artifact of the SDR itself, and that's why the radio didn't receive it. And now I have the real McCoy on 10.7 and we can hear it. So the sweep thing is working here. Now, we could scope the sound in the speaker, see what we see. But there's actually a test point underneath the radio that's really where I should have the scope connected. And I kind of forgot about that in all my excitement here. Let me turn this down. I don't need to listen to that. So I need to hook the scope up to the proper test point. The ABC is sticking out here on a clip lead. Why don't we try that right off the bat and just see what we get off of that. That might be interesting in itself, but that's not the right spot, I don't think. Okay, disconnect the scope. This lead fell off. Okay, I'm going to ground the scope here. Okay, and then here's the AVC clip lead. Let's go on that and see what we get. I'm not sure at all what to expect. We're seeing pretty much nothing. Oh, there we go. So that's a times 10. I don't think that's going to be too helpful in what we're trying to do here. So I really do have to get on the proper test point. It's describing a partial circle there, or an ellipse, from some kind of phase change that's occurring in the signals. So the phase of the signal doing this and the phase of the signal doing that are a little out. In fact, that could have actually been a hum from the radio making that circle there. I don't know. Okay, all experimenting. Now I gotta get underneath there and hook up to the proper test point. Okay, bad planning. I have the radio operating. So I'm gonna stop and do that, and then we'll get going again. Okay, so the test points in here, A, B, and C. The test point that this red clip, the AVC clip is on, is A. Sure doesn't look like it though, does it? Oh, that's right, that's right. That's right, A of 15 going all the way here. Yeah, so this is test point A. That's the AVC voltage. That's not what we should be on. We should be on B. B is this wire that I soldered in earlier. And C is this junction point of, I don't know, it isn't. I'm not sure what C is. We don't worry about it right now. B. I can get at this through this big gaping hole and clip right onto it from behind. That's my plan. Put this down. Okay, so I have the scope here. Now I got to get in behind there. Clip it in. Okay, I have it clipped on. Ground attached. Swing this back like so. Very good. Ready to go for another test. We are ready. Sweep is more or less centered, little broad. Little broad. We'll put it like that. More or less centered on 10.7. Okay, everything's ready to go again. We're gonna start with the dim bulbs. Did a big circle there for a moment on the scope. What are we going to see? Big signal. Brightness. So as crummy as that is, it would look like we're getting the shape of a response curve here. Now, there is some kind of blanking in my signal generator, this old guy up here. But I'm not sure how to employ it. What do we got? What do we got going here? First, let's stretch it out a little more. I can stretch it out a couple ways. Let's stretch it out with a bigger sweep. So what's happening on the screen, on the scope, is it appears as if I've squeezed the display, but really the fixed size of the display is now covering more. as I adjusted the control here. I guess you better see what I'm doing with all this stuff up here. So, you know, big question is this 10.7 right here? So now I want to, I'm on the SDR, I'm changing the width of the display on the SDR so I can see the entire sweep. Looks roughly in the middle still. If I change the frequency I'm sending over, this piece should move around. Let's see if that's really true. Yeah. Now, how am I going to know if that's 10.7? The idea was to utilize the SDR for that. Let me shrink the sweep right down. You can see it's no longer centered, so I'm going to move it. I think that's more or less centered. It's got a very weird shape on the SDR. I don't want to expand it out, but maybe this will throw it off. So I'm looking at the width on either side of the red line. It looks about the same. So I think the sweep is centered. It's not centered on here though. And it's hardly. Part of what's missing is probably using a detector probe. I'm just using a straight probe. With a detector probe, I would get something that would look more like this. Instead, it's full of RF. That's okay. I don't think it's the end of the world. At this point, anyway. So the next thing would be to get a mark of 10.7 on there. I need another signal generator to do that. Okay, that's what I'm going to do. I'm going to bring in another signal generator as a marker generator, and we'll see what happens here. Okay, so I've got this signal generator operating now. It's tuned to just pretty much 10.7. If the output set not too high, the output is on the end of these. What just happened? What just happened now? Wow, the scope has gone off screen, the SDR has gone off screen. What did I do? Did I bump something? Did something suddenly improve? It would look like the output from the signal generator is just shot through the roof here. How could that be? Bumping this cord? Can't even get close to it. I don't know, it's a lot nicer. Let me attenuate it more. It's as if the sweep, we were doing so well. And then what has happened? Let's just tone this down. Got a big circle there now. Something bit the dust. I didn't really do anything here. I just turned on the signal generator, was playing with the output cord. What happened? I was doing so well. Getting so close. Scope leads connected. Things are going downhill rapidly here. This is variations in the operation of the radio itself. So this couldn't have done anything. It's hooked up to nothing. It's all gone away. It's all gone away. Looks to me like the scope lead has fallen off the wire back here. Oh, that's definitely part of the picture. Yeah, it's underneath the chassis where I really can't see what it's doing. To make sense. Nothing making sense. Nothing is making sense anymore. Okay, let's go back to the start. And look at, I dropped the output here quite a bit. Back up. Well, that looks nice. Looks like the same thing we had before. Sweep, a little narrower. Okay, that seems normal again. We had a huge signal on the SDR and a huge signal on the scope. Now I desensitized the scope. Let's resensitize it. Aha! Well, look at that. Now we got twice the signal we had. We got one going up and one going down. It's possible yeah, I don't know if that's really true. I was going to say it's possible, since the sweep is actually like a circle going around, that we're sweeping back and forth and producing, you know, the upper hump and then the lower hump and then the upper hump. I don't know. Not so sure about that one. Okay, let's carry on and see if we can get a 10.7 to show up in the middle of all this schmozzle. I don't know what happened. What happened? I don't know what happened. Stuff happens in here. So how am I going to inject this? I can go right on the same sleeve that's around this tube. This sleeve is only energized by a coil. I'll probably kill. Well, let's just try one lead and see what happens. I mean, this is a radio and it's sensitive, right? So we don't need too much injection. Go right on here. Looks like just doing that is enough to kill it. It's because this is a grounded generator. And well, we can up the output on the signal generator over here. Okay, we've compensated. Now, is there a 10.7 showing up in there? That's a good question. So what the 10.7 will look like, some kind of wavy interference moving back and forth. Here, I'm going to swing this over this way. I'm going to change the, we can call this the marker generator frequency, and watch the display. Okay, I don't see anything. I'm going to up the output. Again. I don't see anything. Okay, we're going to up it more. This is all I got now. Okay, there we are. Now we see it. Okay, you need a good eye to see a little squiggle right here. May not be visible in the camera. Okay, let me just check calibration over here. Signal level is very, very low. That's better. If you don't want any modulation, now you can probably see something happening right here at my finger. That frequency right there is 10.590. We're going to take it up to 10.7 here. 650. 70, 80, 90, 7, 10.7. So for my eye, because I get just a little better vision here, it's just off to the side of the peak. The peak is close, but not right on it. interestingly enough, when you look at the SDR has a peak now at 10.7, right on the red line, and the SDR is responding to the signal coming out of the old signal generator here. So everything is cooking with gas at this point. And this isn't ideal. This is not an ideal display, but it's good enough. The IF is slightly off. That's how I could interpret this. It's slightly off. Oh yeah, now what? Now I've got the radio spun around the wrong way, so I can't get at the adjustments here. Unless I do a very awkward thing. Let's try the awkward thing. Okay, those adjustments were being made with this guy here, I believe. These were the lower guys. Let me turn this a little bit, see what happens. How far can we turn it? Before a disaster occurs. Everybody hanging in there? Everybody? Speakers are not happy about what's happening. There we go. Okay. No, don't. Oh, so you know what? It was this, I think the scope connection. Okay, I'm far enough now to try this. So we're going to go into the first IF can. God help me on this. I don't usually invoke deities in my shop, so okay, so I'm in the first can, and you can see what's happening. Beautiful. But it really wants to be over here. And that's probably because other guys are not in the right place. Okay, we'll go on another can here. Just keep trying to move it. So that this 10.7 marker is right in the peak, which is where it is now. Okay, I'm going to the, wasn't there only 3 I do? There we go. This is the one that didn't seem to make any difference. Am I really turning something? Is something happening? Oh my gosh, it's after lunch. See clearly. I cannot see. Let's put the brake on. Don't give up on me now. I'm so close. Anything happening again. I don't think I'm turning that. That's the problem. Let's grab a metal one here. A little screwdriver. And look for the slot. Okay, definitely in there now. Okay, we can see it moving. Good. Okay, it's having the proper effect. Those are lined up now. They're all lined up on 10.7. All lined up on 10.7. Expand the sweep a little bit. It has the backwards effect of shrinking the peak. You can see it quite clearly here now. Here, how about this? How about that? That's much better. it happens to be all lined up on the center graticule. That's just coincidence. And the marker is right on there too. And it's just hard to see all these things happen. It's all lined up. It's all lined up. Now there's a couple up here I had to do too. Let's fiddle with those. Okay. Can I use a metal thing? Wait a minute, this signal is injected here. How can you possibly do that? What is different? What am I doing here? Do A16, 17, 18, 19, and 20. High side to oh, you know what? This is the converter too. This is the converter too. Well, that's pretty interesting. Let's just move the injection point from here up to here and see what happens. Because it's 10.7 coming out of here. That's right. This isn't converting it. This is converting it. This is the AM converter here. So did I just do everything wrong? Sure. So I'd accepted that doing alignments the first few times on a radio, stuff's going to go wrong. That's just the nature of the game. There we go. Okay, and I shrunk the tube a bit to fit the smaller. There, that's good. There we are. Okay. Very good. Let's shrink this. Now that looks kind of neat. We still see 10.7 right on the spot. Excellent. Now I'm ready to do these two adjustments up here. I think it was harmless what I did. I just managed to inject the signal a little later after the tuner. So now we're going to give these guys a go. These are the transformer adjustments for the output transformer of this tuner. One is the primary, one is the secondary. Here we go. So I think we're trying to maximize the signal. It's pretty maximum there. And now the other one. Oh, don't want that to scare myself. Jeez. That's the top there. Now it looks to me, gotta just move this a little bit to the right here. Oh, I cannot do that. I can do it with this. There, that's better. Stretch that out with the scope. We can see we're no longer on the 10.7 mark here. We're a little off. Okay, so I'm going to go through the IF cans again. See if we can't get them on the mark. Get them, come on, get in there. Now I'm rushing because I know lunch is, it's lunchtime. Okay, let's try that. Back here. That's pretty good. I think what's happening here is, I'm not sure, but this part getting smaller, I think is a good thing. Let's turn down the volume. I'm competing with it. It's more dramatic with the volume, but so get a nice high peak, but back on 10.7. Okay, can just keep monkeying around here. Here. Go on the 10.7, but look at the difference. pushing them towards a 10.7. Okay, we'll go back in here. Oh yeah, this one we need to use the screwdriver. It's just not conducive. I'm examining which way the slot is aimed. Okay, we're in, I think. Ooh, ooh, ooh. Metal screwdriver in a slug, not good. I think I'm in there. Doesn't feel right. My camera started exiting. Hey, look at the boost. Where'd that come from? How did we get a boost on that? Shape is bad. Not sure what to make of the sound. It would look like the sweep has gotten way bigger. Let's just bring it in a little bit. I'm staying away from this one because I think I remember this. There's 5 of them. That's not one of them. 5 adjustments. 2 of them are up here. So it's 1, 2, 3, 4, 5. This one is for something else. Okay, we'll go back in here. Hey, what are you doing there? This is a hair trigger. The scope. Go back in here. So to some degree, doing this with a see, we get a much nicer shape out here. Doing this with the single frequency is not as brain teasing as trying to do it this way. Everybody wants to go over here. Just keep working at it. We still have the ones up on the top. The tuner. The 10.7 at the top, but look at the shape is all off. Let's go up here now. Try this. There we go. Ooh, that's a lot better. That's a lot better. Go here. Now, is this going to boost the output of this radio? Get in there. There we are. Getting a nice symmetrical shape. Just a wee bit off the 10.7. Just a hair amount. A hair amount. I'll take a hair amount of that, please. This way, just a wee bit. That's looking wonderful. On most of these radios, the bandwidth is set by the way the coils have been built. So you just got to line it up. The bandwidth will automatically be correct. We're still on 10.7 on the marker. By Jove, I think we've done it. I think we've done it. Okay, have we really done it? So, take off the injection. Try not to pull the tube out. It's a little warm. So now for an antenna, we have nothing. We now have nothing. nothing for an antenna. Oh, 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 oh. Look out, man. Almost stumbled my way into a disaster there. So for a semi-decent antenna, something that's going to do something. Okay, a pretty long piece of wire here. Fantastic. Goes right in. Fantastic. That's half a dipole. That would be a monopole, I guess. Get the other half here. This should be a sufficient antenna to. No, that's not it. Should be a sufficient antenna here to judge the quality of the radio. Okay, other half. I'm going to hang one half over here. So I'm just stretching them out, and the other part over this way. Throw it up there. Nope, didn't work. Throw it up there. Okay. What do we do? Volume down. I still have the scope connected. Why don't we disconnect it? So it can't be part of the picture. All we got now is a radio and an antenna. Nothing else connected to it. So it's probably picking up the sweep generator. I think I'm done with it. Boy, I feel a lot of heat in here. So I'm going to turn off the sweep. Get it out of the picture. Stop my scope from burning out on the screen. Let's do this. Get it sweeping. Okay, radio. This is your chance. That's pretty good. Everybody stand back for this. Come on, baby.
We can tell them that electrical signal disappears, and that tells us what the minimum level of sound is that they can hear at a particular frequency.
So you're listening to a brain response within the brain itself.
That is correct.
What do you expect the range of hearing might be?
That's a very good question. Most of what we know about whale hearing
Lots more volume.
anatomically modeling. And for this species in particular, we think it may hear somewhere between 20 and maybe even as high as 40 kilohertz.
Put that in perspective for me.
Well, the human range of hearing for a young, healthy person extends up to about 20 kilohertz. So it's possibly similar to that of a human being. It may extend to twice as high as 40 kilohertz.
I'm just interested in what they're talking about.
Now, would you expect what you heard from Mickey's to be similar for larger baleen whales like humpbacks or blue whales?
Whale hearing.
We anticipate that the larger the animal becomes, that there might be a shift in the frequency range of hearing for that animal.
Okay.
And certainly for animals...
Let's try some other stations now. So this is a mono station, but this is a mono receiver. It's actually a mono FM station there. The CBC, my local CBC transmissions. Let's get some music on here. Sensitivity's good. Better, not good, but better. So there's probably a limiter circuit in here, a tube acting as a limiter, although I didn't notice one. And it sounds like the FM signal is not strong enough in the radio to accommodate the operation of the limiter, which is why we're hearing a hiss, even when we have it tuned in. These radios have to be tuned very precisely on FM to sound proper. They don't have any automatic frequency control in them. Okay, what I'm going to suggest at this point is more alignment is needed in terms of like an RF alignment right up here in the tuning box to get this guy to really come out. I don't think there's anything of sorts further down the line. I don't think. Could be problems in the FM detector, but I think the hiss, persistent hiss in the background, says the signal at the start is not all that strong. So that's the deal up there. Would there be a component problem in there? That's my answer to that. So thanks a lot for watching. It's been a tough slug, but I think I got through it all and got some meaningful work done on the IF. Great. So thanks a lot for watching.